All right, let's continue with our quiz review. So now we're on part 2, quadratic functions with objects in motion. So I've got an example here. I have h of t equals negative 4t squared plus 32t plus 80. This models a ball thrown vertically up in the air from the top of a cliff. Its height above the ground is approximated by the function given. H is the height in meters and t is the time in seconds. So it's asking us to find the zeros. So let's talk about that part first. So let's see, make sure you can see my calculator screen. I typed in the function, and then when I hit graph, I don't have the best view of this function, but keeping in mind that it is the model of a ball thrown vertically upward from a cliff, I don't really need these negative numbers because I'm not going to have any negative height or negative time. So let's go to window and take away the negatives and turn the minimum values into 0, because that would be a minimum height and a minimum time that would be reasonable. Then let's hit graph and see what we have now. So I still need to make my graph much taller. So let's go back to window and make the y maximum, let's just try 100 and see if that looks better. So it could still be a little taller. Go back to window. Let's see about maybe 200. So that gives us a decent looking picture now of this ball that's thrown in the air on a cliff and then lands on the ground over here. Now it says to find the zeros. So the easiest way to find zeros is check your table and see where y equals 0 is what you're looking for. So I see -2, which doesn't make sense because I don't have negative height or negative time, but it's still a 0, and that's all they asked for. So then 10 is where y also equals 0. So if that's the only question they ask you for, you can put both, even though the negative would make no sense with our problem. Those are the two zeros. The coordinates of the vertex, we can look in our table. We can actually start to see a pattern. You see how you have 108 on either end, and then 128, and then 140, and in the middle would be this unique pair of numbers that have no other pair like it. So we have 4 and 144. So in this polynomial, we can find it in the table. If not, you can always do second trace, and we can go to 4 for maximum, and we could just trace, or we could type in values. So we go to the left and hit enter. Go to the right of the vertex and hit enter twice, and it would land, and you can tell that's pretty much the same thing I saw in my table, which is 4 and 144. So the time when the ball hits the ground, so looking at this graph, it goes up in the air and hits the ground over here, and I already found my 0 over there would be 10, so I know that it's 10 seconds after it launched that it hit the ground. And then it says find the maximum height reached by the ball after how many seconds is that height reached. So that goes with the vertex also. That is what the vertex means in context. After 4 seconds have passed, the ball reaches a maximum height of 144 meters. Notice like height as a function of time is your y value, time is your x value. So that's how we could easily interpret these two numbers to fit the answer to this question. And what is the height of the cliff? So the height of the cliff would just be your starting point right here. It's also at time 0. So at time 0, we can see that time 0 would give us a height of 80 meters. We can also know that the initial or starting point is our y-intercept. So either way you want to think about it, it would be 80 meters. And then what is the height of the ball at 8 seconds? So we just need to go to 8 seconds in the table. And after 8 seconds, it is 80 feet in the air again. So that means that it went up, and then after 8 seconds, it was actually level again with that cliff that it left. So we would just say at 8 seconds, the ball is 80 meters in the air. So that's it for this function. There'll be another video to follow for the next part of the quiz.